Hello everyone. In this session, we are going to discuss about TCP/IP model, addresses used in TCP/IP model and their usage. On your screens, you can see 7 layers that belong to OSI model and the names are physical, data link, network, transport, session, presentation and application. Let us begin with the discussion on TCP/IP model design. From OSI model, which is a standard or reference model, how TCP/IP model is designed that you can see on your screens now. The first layer is formed by merging the functionalities at data link layer and physical layer. It becomes a lowest layer of TCP/IP model and that is named as host to network layer. As for network and transport layers, these two layer functionalities are kept as it is, intact without changing anything, and there are alternate names to these layers. Network layer is also called as internet layer and transport layer is also known as host to host layer. As for session, presentation and application layers, the functionalities of all three layers are combined to have application layer, which is the uppermost layer in TCP/IP model. So TCP/IP model is with 4 layers. This is the hierarchy. First we have host to network layer where the functionalities of data link layer and physical layer are merged together, grouped together. Network and transport layers kept as it is, and session, presentation and application layer combined together to form an application layer. So we have 7 layer OSI model, we have 4 layer TCP/IP model. And there is a point to be noticed. TCP/IP model is named after 2 protocols used at transport layer and network layer respectively. So TCP, transmission control protocol, is used at transport layer and IP, internet protocol, that is used at network layer. These 2 protocols are of so much importance that the whole model is named after these 2 protocols. Now the next point is addresses used in TCP/IP model. There are various types of addresses: physical address, logical address, port address, special address, URLs, email addresses. Now, where in TCP/IP model these addresses fit, that we are going to observe now. So corresponding to host to network layer, we have lowest level of address, which is known as MAC address or hardware address, or alternatively called as physical address also. At network layer, we have logical addresses. At transport layer, we have port or process addresses. And at application layer, we have special addresses or URLs. URL is nothing but Uniform Resource Locator. So these are special addresses which need not be represented mathematically. You can represent with their names. As we represent email addresses with specific names and then in the background they get converted to IP address. So email addresses are also known as special addresses. And so users deal with special addresses instead of dealing with MAC or IP address respectively. As for MAC address or hardware address, why is it known as a hardware address or a physical address? Sorry. There is a device which is called as NIC, and the hardware address or MAC address of your machine is associated with that NIC. NIC is nothing but network interface card, which is the device that is responsible for the communication over the LAN. If your machine doesn't have NIC, your machine cannot participate in the communication over the LAN, or in short, it can't be connected to the LAN. So NIC is very important physical component or hardware component that is available at the second layer of OSI model, that is data link layer. NIC is also known as an adapter, right? When you check the IP address or MAC address of your machine, you will get to see list of various adapters that are available. Those adapters are nothing but NICs, that is network interface cards. The hardware address or MAC address is embossed on your NIC. If you just remove the NIC from your machine and just turn it around, you will be able to see MAC address written on NICs. So these addresses, MAC addresses, are also known as hardware addresses because they are associated with specific hardware, or they are physically present on a specific hardware. To give you an example, if you have two machines available and machine 1 has NIC1, right? So along with machine 1, the MAC address of NIC1 is associated with a specific hardware. If you remove that NIC from machine 1 and if you shift that NIC to the adjacent machine, which is machine 2, along with NIC, MAC address will also move to machine 2. Now MAC address will belong to machine 2 because NIC is moved from machine 1 to machine 2. So that much is sufficient for you to give an idea that why MAC address is known as hardware or physical address. The simple reason is MAC addresses are associated or belong to specific hardware or physical devices. Unlike MAC addresses, IP addresses are not assigned to specific hardware. IP address is assigned to a system when the system is operating or connected on a network, and the addresses are said to be logical because they are not certainly assigned to specific hardware or specific physical device. Then comes port or process address. Now what port or process address is? Our systems are multitasking systems. So at a time on our machines, there are multiple processes that are running in the background. Depending on the process, the delivery of the data is to be made to that process by the lower layer. Now consider the example of the TCP IP model on the receiver side. Consider that this is the receiver side of TCP IP model. So the data will come through physical medium and first it will reach host to network layer. After undergoing certain processing, it will finally reach the application layer. But at the application layer, there are multiple applications that are running, or rather there are various processes that are running. So the transport layer should decide, or at the transport layer, the decision has to be made to which process the data packet must be delivered. This process or this one, right? So that is identified with the help of process or port address. So process or port address is nothing but identification of specific process that is running on the machine. Let us proceed. These are few questions for you. Have you come across various addresses used in networking? If yes, then in which context? Half of the answer we have already discussed. You can think over it a bit and then come up with the answer. Second question is how to check MAC address and IP address of your machine. Please find out how to check it. In the lab sessions, individually, we will be able to see MAC and IP address of the machines. The next topic is the addresses used at which layer, addresses used at specific layer for which purpose. So MAC addresses are used for hop-to-hop communication. IP addresses are used for host-to-host communication, and port addresses are used for process-to-process communication. To understand this better, let us proceed and see the next slide where a simple example of a smaller network is shown. We have two PCs, PC A and PC B. Assume that PC A is a sender and PC B is a receiver. In our simplest setup, PC A is connected to corresponding switch, that is switch A. Switch A is connected to router A. Router A is to router B, and through switch B it is connected to PCB. So when the data packet is moving from one location to another location, it has to take this path. That is quite obvious. Now we will see which addresses are used for which communication. From PC to switch, the data transfer takes place with the help of a MAC address. Now there is a logical reason behind this. MAC address is operated at the data link layer. We are talking about OSI model. So switches operate at data link layer and MAC addresses are used at data link layer. So basically switches operate on MAC addresses. So the data transfer through a switch will take place with only MAC addresses, right? So the communication between PC and a switch will be with the help of a MAC address. From switch A to router A, again we will be using MAC address because we know that router has LAN side as well as WAN side. So router operates on LAN cards as well as WAN cards. Those are WAN cards are used for communication outside the LAN, and LAN cards are used for communication inside the LAN. So for this communication switch to router, router's LAN card will be used and it operates on MAC address again because one switch is a party to that particular communication. Between router to router, obviously there will be IP addresses used. Router is a third layer device and IP address also are used at third layer. When I say third layer, I mean to say the third layer in OSI model, that is network layer. Similarly, on this receiver side, router to switch will happen with the help of a MAC address and switch to PC again with the help of MAC addresses. So this slide gives you an idea how the communication takes place with the help of MAC or physical addresses and IP or logical addresses. This should be sufficient for you to understand that within the LAN, MAC addresses are used and outside the LAN, IP addresses are used for communication. Coming back to the last point, PC A to switch A, we are using MAC address. Now assume that this is the data packet that is being transferred. Now this data packet, when being transferred from PC to switch, must be having two MAC addresses. One is source MAC address and another is destination MAC address. So for this example, source MAC address is MAC address of PC and destination MAC address is MAC address of the switch. Once this communication is over, now the data packet lies with switch A, okay? And hereafter the data packet has to travel or take this path. For this, the source MAC will be switch's MAC and destination MAC will be router's MAC. So in this step, the addresses, source and destination MAC addresses used will be changed when we transfer the data from switch to router. Now switch's MAC address will become source MAC address and router's MAC will become destination MAC. Okay, same thing will happen on this side as well. In this case, router B will be source MAC and switch B's MAC will be destination MAC, and for this communication switch B's MAC will be source MAC and PC B's MAC will be destination MAC. Why did I tell you the same thing for 4 examples? Just to make you understand that MAC addresses change every hop or every step, right? When we consider the communication, here we need to take 2 steps: data transfer between PC to switch, and second step is data transfer between switch to router. Third step would be data transfer between router B to switch B, and then this is the 4th step. So as you can see or observe on the slide, in all these steps 1, 2, 3 and 4, source and destination MAC changes every step or for every hop, and that is why on the previous slide we have seen that the MAC addresses are used for hop-to-hop communication. I hope the idea is clear. Speaking for IP addresses, if you consider the same example, the data packet that is being transferred from PC A to PC B keep on changing MAC addresses. But this data packet must also have source IP as well as destination IP. Now source IP for the data packet will be IP address of PC A and destination IP would be IP address of PC B. In no way we can change the destination address or destination IP of the data packet, because that is the basis on which the data is being routed in the appropriate direction, right? If we keep on changing the destination IP, final destination IP, the data packet might not reach the desired destination or the receiver. So destination IP remains the same throughout the communication, and so as source IP, because original source is also not changing and final destination is also not changing. So throughout this communication, source IP and destination IP that is carried by the data packet remain the same, and that is why we say that the IP addresses are used for host to host communication. So for the communication between two users or two hosts, IP address remain the same throughout the communication. Now let us proceed with the next concept of port addresses. Now consider, we have also discussed that there are multiple processes that are running on the machines. So we will take an example of Alice and Bob. Alice is a sender, Bob is a receiver. As you can see that Alice is running two client programs. So Alice is being client for two applications or two processes, right? And Bob is running corresponding servers. So app1 server and app2 servers are available or running on Bob. Now when Alice app1 client wants to communicate with the app1 server, it will have to send certain data packets with requests. Okay, client has to make a request to the server for establishing the communication. There is the whole network in between, network of multiple routers, right? So the routing procedure is usual. In usual way, the routing procedure will take place in this case. Okay. Now when the communication starts, this will start by generating two different data packets by app1 client and app2 client, right? So as you can see, two data packets will be generated at the application layer of Alice, and after undergoing certain processes, finally from Alice they will come out in the network, and then finally it will be given to the network, to the intermediate routers for final destination. So now two data packets will be sent by Alice. One data packet will be app1 client request and another data packet will be app2 client requests. Okay. Finally, after following the usual routing procedure, those two data packets will reach the destination, which is Bob. After reaching Bob, now to reach this from Alice to Bob, we will have to, that communication will need IP addresses of Alice and Bob. So source IP would be Alice IP and destination IP would be Bob's IP. Throughout the communication, source IP and destination IP would not change. So both the data packets that are generated by Alice and ultimately generated by app1 and app2 clients will have same source IP and destination IPs. After reaching Bob, now at Bob, the use of IP addresses is over, right? Because routing is being done. After reaching Bob, now Bob has to decide to which server it should deliver that particular data packet. And here comes the role of process address or port address. So each data packet is assigned with a specific process address or port address, and it will be delivered, the data packet will be delivered to appropriate process using that port address. So after reaching Bob, the two requests will be respectively delivered to app1 server and app2 server with the help of port addresses. So this is the use of port addresses. Now let me give you an example, simple example which might clear the concept of port addresses more. Consider the example where two siblings wish to meet their friends where both the friends live in the same house. So two siblings will leave their house and they will start moving towards their friend's house, right? So now in this case, both of them are starting from the same point and they will arrive at their friend's house, which is also a single point, right? Their friend's house. After reaching the friend's house, now they will have to meet their respective friends, and here they will go in different directions. Probably one sibling will go to his or her friend's room and other sibling will go to his or her friend's room, right? So here in this case, both of them started from their own house. So both of them have same source IP. So that house IP is known as source IP. Friend's house IP will be destination IP, and both of them are taking the path with the same source and destination IPs. After arriving at the friend's house, they will go to different rooms probably, and those room addresses are nothing but port or process addresses. I hope the idea of MAC address, port address and IP address is clear, and the uses of MAC, port and IP addresses are also clear. At the end of this session, let us take a few questions. Is port address physical or logical? You will have to find what physical port and what a logical port is. And second question is, if you are sending an email to your friend in the US, how many times the IP address shall change in the whole communication, during this whole communication? And please justify your answer. The answer is being given to you during the session. Try to find out the reason for the same for this. We will now end this session. Thank you.